Morning, everyone. Thanks for being with us today. I'm Nicola Zazzari. I'm a project manager at Trusted T. We are coordinators of the ALLPROS.eu project. Thanks for joining us today in this webinar, which is actually the second in a market trends webinar series, which is co-organized by IDC and is looking to give us some insights of what is going on in the microprocessor and semiconductor sector, especially. The series is organized by the ALLPROS.eu project, which is a CSA, so a coordination and support action funded under the Digital Europe program, is looking at strengthening Europe competitiveness in semiconductors by engaging with various stakeholders in the microelectronics value chain. In the context of the projects, we intend to provide, market trends, gap analysis report, policy brief, and also a digital observatory of best practices around the semiconductor sector. And this webinar really fits in this whole, let's say, aim. As I was mentioning, this is the second in the series. You will see today's agenda. We have a representative from the European Commission, IDC, Intel, and EMEA, which are going to steer us into the impact of generative AI into the semiconductor sector. This is the agenda for today. Just a couple of words on housekeeping. So here you can see we have a diverse audience which is joining us online. So thank you for doing that. I kindly remind you to post your question in the question and answer chat you will find in the central part of the Zoom. You can use the chat also to discuss among yourself. At the beginning of the question, please also try to type the name of the speaker or the topic so we can quickly address that. And I kindly remind you the slides and recording of this webinar will be made available and sent to you as soon as the webinar ends. So without further ado, I will just pass the floor to Thomas. Let me just share my screen again from the European Commission. Just 1 second.
Yes.
Can you see my screen? I think so, right?
Yep.
So Thomas, the floor is yours.
Yes.
Just let me know when you want to change the slide.
Yes, good morning, everybody. It's my pleasure here to give you a short introduction about what the European Commission trying to do and about AI chips, where we're standing, and if we seeing that it's a hype or if we need to do something. Next slide, please. On this next slide, you see basically semiconductor market trends for different components. This is a study here from International Business Strategy from 2024, which clearly shows that there will be in the future from 2025 quite a steady increase of semiconductors. Next slide, please. The same is actually true when we're seeing the study here from Gartner. They also predicting a quite significant increase of semiconductors driven basically by artificial intelligence chip market revenues. Next slide, please. And if you see here from another one, Morgan Stanley Research estimates, also claiming that there will be a huge amount of, with more or less 30% or even more chip market revenue increase, basically driven mainly by cloud computing. Next
Thomas,
slide, please.
sorry, can you So we hear like a disturbing noise. So
Okay, I try to say.
can you maybe turn off your camera? Maybe.
I'm trying to use. Yeah, maybe. Okay, I try to use the other microphone and stop the camera.
Yeah, it
Okay,
seems better now.
I hope this is better. Okay, so all this market studies basically clearly shows that there's a huge increase now for and driven by artificial intelligence chips. Next slide, please. If you see, then most of this markets which we have seen is driven at this moment by NVIDIA. So we estimate that more or less more than 90% of the AI chips coming from NVIDIA. And from their side, you see the major markets which they are driving is for data centers. Next slide, please. If you see NVIDIA revenue by on the world, this is you see the US is the major country who puts in data centers and driving basically the revenues of AI chips. Next slide, please. So what we see here in Europe. So in Europe, we see that we don't have basically too much presence of data centers. We have there on the industry side, we have many solutions based on ARMS cores. But in the IDMs in Europe, NXP, ST, and things like and other companies don't have actually products on edge AI chips, so microcontrollers. Their strength is mainly on automotive for the automotive OEMs, but not on that side. We have a lot of range of SMEs who are working on AI processors and different approaches. And we have quite substantial research on low power edge AI solutions and others. Next slide, please. So if you see in the world, this is a kind of a race now going on. China is putting up a lot more efforts on artificial intelligence chips. They are blocked for low nanometer capacity since they don't get ASML equipment. But CIMIC has already shown that they can fabricate with normal lithography by 7 nanometers chips. In Europe, for AI chips, we're struggling a little bit. We have no really advanced node yet. There are some plans that, for example, Intel is upgrading their fabs in Ireland, and basically also there will be some fabs in Germany coming up. But we have still some good research, like mentioned here, for UDM, so process and memory solutions, and Profis and Neuro for vision products. Next slide, please. So what's our strategy? So our goal is basically device that deploy all modems interfaces, devices that operates in systems and edge computing. So there we would put more emphasis on it. And next generation of machines learning accelerators for data centers. How we will do that? We will support champions here in the field. We will, as usual, leverage our research. We identify different streams. So we have an application push from embedded systems, 6Gs, automotive, so where Europe is actually quite strong. And we coordinated EU hardware and software strategy. Next slide, please. And I think that's it from my side. Yes. So this is basically a short outcome what we're trying to do here. I will give now the floor to Luis Fernandez from IDC.
Good morning, everyone. Nicolo, if I may.
Yeah, go ahead, Luis. Just a quick reminder to the audience. So if you had any question, please write it down in the question and answer chat here in Zoom, and then we'll address it during the specific session. Thank you.
Sorry, Nicolo, I need you to allow me to share.
Yeah, you should be able to do it.
Okay. Here we go. Okay, you should be seeing my screen now.
Yes.
Good morning, everyone. My name is Luis Fernandes. I'm a senior research manager at IDC. I usually look at EMEA, so Europe, Middle East, and Africa, and we look at a thing called Future of Digital Infrastructure, which is basically server storage, data center automation, and orchestration, but also things like hybrid cloud, interaction with the semiconductor industry, with the OEM industry, with and customers, obviously, and system integrators as well. Today, I'm going to do a market presentation connecting a bit the silicon landscape, so basically the semiconductor industry and the whole supply chain, and compare that to the new trends that are coming from AI and from GenAI. So we're going to look at a little bit of market perception from the end customer, something that Walter will be touching on afterwards as well. What that means for IT and for CIOs across Europe, because that market perception is sometimes maybe biased by business line managers or CEOs, but then IT and CIOs have to deal with the brunt of the focus on GenAI. And then we'll touch upon something that is very close and dear to the EU, which is power consumption and ESG. So the whole point is these new workloads are consuming huge amounts of power, and basically the power grid needs to be prepared, or the whole industry needs to be prepared to handle those huge workloads in terms of power consumption. So starting off with the perception around the market and how AI fits into this. Now, this is curious because this particular research we actually did before the release of ChatGPT, which was obviously a huge boom to the whole GenAI conversation. But at that time, in May 2022, the enterprise companies in Europe were already putting AI on top of their performance-intensive computing workloads. So you had several performance-intensive computing workloads, and AI was already number one, even before the hype. They had the major workloads. They were the most critical of all workloads. And on top of that, and very important to our discussion, was that this was the workload that most of the companies felt required a dedicated infrastructure. It could not be a shared infrastructure with other workloads. It had to be dedicated at times because of specific hardware components, other times just because of sovereignty concerns or security concerns. This is this is from the same, on the left, the same survey, the same research that we did. As you can see, 23% are significantly investing in generative AI in 2023. So in 2022, they were hoping to invest 23% of them, and 58% were going to explore potential use cases. So if you combine the two, you can see that 4 out of 5 companies were already thinking in 2022, were already thinking about doing something around GenAI in 2023. Now, most of those workloads we've seen have come from these 3 big topical workloads. Then there's specific workloads for each, but it's basically number 1 comes always customer and employee experience. Second one has been software development, test and dev, test creation, business processes, task automations, that sort of thing. And then the third workload has been around co-pilots, training, content creation, content management, at times translation, things like that. Obviously, Thomas has touched a little bit on that. It's unavoidable almost to not speak about NVIDIA. We have here a list. This is from public records. The top titans in terms of IT, the tech titans that are in the New York stock market. And obviously, NVIDIA has grown immensely. These are the numbers for 2023. For the whole year, and this is actually the number for Q1 2024. As you can see, NVIDIA is right there on the circle. Obviously, NVIDIA has grown immensely these past few times, exactly because of GenAI. Obviously, there's a caveat here. What we have been seeing is that NVIDIA, in fact, is growing very much, but it's growing on top of just a few customers. So we know that it's basically Meta, Microsoft, and then on a second note, Google and AWS. So they're selling most of their data center components to very specific customers. Now, the problem is those specific customers are in a build-out phase. They're buying up everything they can because they're building huge systems. The problem is when that build-out phase ends, basically, and they stabilize, NVIDIA will have to turn to their more traditional partners, which at this time, they haven't been able to address in terms of orders. So as you can see here, some of the OEMs like Dell, like HP, like Lenovo have been struggling to address all the needs. It's usually a good problem to have, which is they have a lot of orders, but NVIDIA has been unable to secure a stock for all of them because they're providing to these smaller in number but very big in orders customers, and there needs to be a balance. There needs to be the opportunity to satisfy these key partners, because these key partners will be the ones that will be developing the market in the years to come, not exactly the public cloud providers, and we'll see why we say that. Going into the public cloud, these are the numbers of the public clouds growing and the size of each one. So as you can see, they're still growing. They still have a healthy growth rate. However, when we look at the numbers for private cloud, public cloud, and very specifically in Europe, we can see that in Europe, there is a big appetite for hybrid cloud. Very little companies want to use the public cloud only. So some startups, we see that they use the public cloud only. As time goes by and they grow, they tend to revert some of that infrastructure back to private cloud. So we're going to need those other partners to fill the gap. On top of that, when we look at specifically GenAI, what we're seeing is most of the CIOs are willing to use the public cloud to run things, to run pilots, POCs, to build test and development environments. But then for the most part, they want to revert back to the private cloud to run their production in private cloud. So as you can see here on the left, you have the companies using public cloud just to run POCs or build tests. And on the right, the companies that are willing to use public cloud for everything. Obviously, there's a preference, there's an appetite for the private cloud, which is in line with what most European companies are saying. Most of them is because of digital sovereignty issues. Others is just legacy traditional environments. There's a lot of reasoning behind it. However, we do see that tendency happening. The good news is from a business standpoint, most of the CIOs are now looking into IT as less of a burden, less of let's say a danger, or just something to spend money on, and more something as a competitive advantage or a differentiation to create new revenue streams. Regarding GenAI and regarding budget, what we've seen is that although IT leaders are actively engaged in terms of budgeting and in terms of decision making when it comes to GenAI, there's a bit of a disconnect between the CIO and the IT leadership and the business leadership. So this could lead to problems down the road where the business is going in one direction and IT is going in another direction, which actually plays into Walter's presentation as well when he speaks in just a few minutes. And one curious thing that we've seen happen in 2023 and hopefully will change in 2024 was that a lot of those GenAI projects that everyone is very hyped about, the budget for those projects wasn't actually being created, new budget. What they were doing was most of the companies were diverting some budget from other IT projects into GenAI products. Now, obviously, this is not sustainable in the long run, and hopefully there will be a shift in 2024, but if not, it will have to happen in 2025. There will have to be specific budget for GenAI projects because every other project cannot be stopped just to focus on GenAI, just to divert all attentions to GenAI. For the last bit of my presentation around power consumption and ESG, I would like to leave you with a small riddle for you just to set the tone here. So basically, the global proportion of electricity or power consumption by data centers is estimated to be 3% in 2022 and 4% in 2030. Obviously, this data keeps getting updated, but if you think that in 2015, Ireland's the called Emerald Island already was consuming 5% for data centers, what would you think this proportion was in 2021? Now, one would think that it's in line with the previous prediction, right? So it would be around 8%. However, it's actually 14%. And from what I've seen, this is a prediction actually from 2021, the data from 2021, and is now also out of date in terms of the 14%. What that has created is a situation where, in the case of Ireland, the government has actually requested a moratorium on creating new data centers. The power grid just cannot handle the amount of growth that they're experiencing, and there's other examples around the world where the same thing has happened. The power grid cannot keep up with the demand of these data centers. Now, obviously, this happens. And it's becoming a huge concern. It used to be one of the least important factors when it came to decision making in terms of IT, and it's now becoming a huge criteria when answering RFP responses for infrastructure, for procurement of infrastructure. So it used to be just the leaders that were concerned about power consumption and ESG criteria. Now it's going into the mainstream, and even those laggers, those companies that are a bit more conservative in terms of IT investment. So this is something that we need to look very clearly and address passionately, because otherwise we won't be able to sustain the level of growth that is demanded by the industry. Now, one way we can do this is that instead of looking the same way that we started looking to IT to start new revenue streams, we can look at sustainability as an initiative for competitiveness and how to create new revenue streams and create operational efficiency, and therefore gain new revenue streams from sustainability. These are a few examples. Those are the most common ones. However, this has to be something that has to be addressed across the company. It can't just be the IT department. It has to have stakeholders up and high. This is the three pillars of the tech sector. These three pillars are actually a very good framework on how to address sustainability in the European landscape. So the first thing is you have to monitor what you're doing. So in terms of power consumption, in terms of ESG, that goes into the tech vendor performance. So looking at what your equipment is doing to be able to do something about it. Then technology as an enabler is to use that technology after you monitor it, use that technology to be able to address your goals, whatever the goals might be of the company, whether it's regulation, whether it's the company itself having these targets. You can use that equipment, that technology to address that. And the final point is the tech for good. So the part of having non-for-profit activities and a corporate social responsibility to help out the community as a whole, not just the company itself, but using technology for that increased role. As a final point, or two final points actually, I would just like to go back to what we were speaking before, how Europe prefers a private cloud versus a public cloud. We need to address how we're creating our data centers, because obviously there's an appetite for private cloud, but typically private data centers are not as efficient, and obviously operationally are not designed as well as a public cloud provider or even a third-party data center provider. So we need to look into what we're doing in terms of building data centers and the use of data centers to try and reach, whether it's in this particular slide, this case, we're using PoE as a metric. A lot of companies don't use PoE, some use, some don't. It's not about the metric itself, but it's about to try to engineer the facilities as a whole, looking at the whole ecosystem of infrastructure to be able to reach levels that are optimized closer to what a huge company like a hyperscaler obviously can do at scale, but try and mimic that and try to get closer to that, rather than having just a technical room that will make shift, but is not optimized for these types of equipments and these workloads. And as a last slide, I just wanted to show you, showcase the past 10 years, how it's been. If you talk to a data center provider, typically 10 years ago, they would be providing 7.5 kilowatts per rack, a 42-inch rack, 19-inch standard rack, 42 U's of height would use up 7.5 kilowatts. Then around 5 years ago, we went from 7.5 to 15. Nowadays, we have racks consuming anywhere between 65 kilowatts up to 100 kilowatts. Obviously, this has to do with new workloads, new accelerator, GPUs, that sort of thing. But it's, as you can see, it's completely The way we've been doing business until now is completely unreasonable going forward. So we do have to rethink how this is done. And hopefully we can build data centers that are prepared either from power grid perspective or in new ways of cooling and new ways of power internal dissipation that will be important for the new workloads going forward. That is my presentation. I'll be quietly in the back now answering any questions you might have in the chat. And next, I would like to introduce Walter Riviera. He's from Intel, and he will talk to us a little bit about Intel's perspective on GenAI and its impact in the semiconductor industry. Thank you so much for your time, and hope to talk to you soon. Thank you.
All right. Good morning, everyone. So let me share the screen. All right. Can you guys hear me okay?
Yeah.
All right, cool. So thanks, Luis, and thanks all the other previous speakers for painting the picture about the impact that GenAI is having. I would like to demystify some of the concept because it seems AI only existed after ChatGPT, and there is a BG and AG before generative AI and after generative AI, but in reality, it's not like that. AI has always been there. So the ambition of this next 20 minutes together, it's really to demystify some of the topic and go beyond the hype, because that's disrupting as well. And just to share with you what are the trends and the must watch behavior in case you're planning to develop AI. Well, Intel is now on a journey for bringing AI everywhere, and that means from data center to the edge and inside outside our working hour in a responsible way, of course. AI, it's going everywhere, whether Intel is following or not. AI as a kind of a revolution is going that way. So again, there's been a rapid growth. You can see we went from machine learning, my beloved one, I would say, because that's where I started, then deep learning, then now it's all about generative AI, but the next step is AI everywhere. And we need to tackle the challenges that this journey involves. And the first one is complexity. The models are growing. We're going to see that in a couple of foils. The cost, I think Luis painted an amazing and extremely detailed picture about the cost, which I would only complement by adding the skills required to implement such solutions. The cost for operationalizing it, meaning putting that in production, going from research into actual production, brings challenges as well, and costs associated to it. Last but not least, actually, the first two you see in the bottom are not in the bottom because they're less important. Arguably, they're more important. The data security and privacy, and we're going to spend a couple of minutes on this in the next few foils, because yes, everyone's talking AI, and rightly so, but the superstar is the data. AI is an application that can run and can take advantage of the data, but the data are actually reshaping the way we build infrastructures. I'm going to share an example very soon. Last but not least, actually, the foundational part is the human impact. So Intel is fully committed for a responsible approach in adopting AI. And this means enhancing the internal teams with legal to review our project where we're directly involved, and as well as taking parts to collaborations with partners. For example, the C2PA is like C2C, Content Creation Provenance Authority. This type of new certificate, new partnership that are rising up to authenticate the source of information that can be checked at the beginning when a new software, for example, photo editing, needs to check that the photo is actually genuine, and the device that acquired that picture can put a hidden mark on that picture to witness that is a genuine content. So all of these initiatives are part of the human impact and the responsible AI approach. Now, here are some trends to watch. Okay, so let's try to go beyond the buzzword. What does it mean to make AI real? At least this is all coming from direct experience in the field that I'm collecting. I look after the EMEA for the data center side of the Intel planet when it comes to the AI technical support. So what does it mean to stay secure and responsible, and what to consider to make this happen? So as I mentioned before, the first disambiguation it's critical to highlight is that AI, it's like a something that is capturing the attention from everyone, like a prestige game. But in reality, the main focus should remain on the data. Data is the rock star that is changing the way we build infrastructure. What you're seeing here is the picture of the world, and that is shaping up with where you have data silos and, for example, HPC, like high performance computing infrastructures. With the rising of data regulations, and in Europe, as we've learned from Thomas at the beginning, we do have the AI Act, the GDPR. We have the HIPAA in the United States, PIPL in China, the POPIA in South Africa. Now the challenge is, okay, let's take a step back and let's put ourselves in the time of COVID, for example. How amazing would have been if everyone would have shared the data. Every hospital would have shared the data about, chest radiographers to spot the different type of COVID, for example. I'm just making up an application here, but you can work something more realistic. That would have been amazing, and the good of it would have been for everyone. Arguably, to make that happen, we would have need data, okay, a model. Again, the literature is full and is mature from that perspective, and compute. And again, Intel can help with that. We had all the ingredients, and we still have all the ingredients. Why nobody is baking that cake? Well, the answer is because of two layers of difficulties. The first one is data regulations, which are in place for a reason, and rightfully so. The second is, even if you take the regulations out of the equation for a second, how would you practically do this? Would you send out track full of SSDs or hard disks and copy all the data from all the hospitals and to move it where? Who would be the owner of that new location? It would just be unfeasible. So there is a new paradigm that is rising up. It's actually not new. It's been at least 5 years, since 2017, out there. It's called the federated learning. And now I can play this short video and while I talk through it. So basically, you have the hospitals, you have a model, the same model. Each hospital trained the model locally, and then when the training is done, they share the model back to an aggregation point. The aggregation, as the name suggests, fuse the model together. Then it clones the copied model and it sends it over. And that's an iterative process. There are many variants of this in case you want to do it for IoT, or in case you want to put a insurance company collaborating with a hospital, for example, so sharing different type of data. But the concept is, this is how data are reshaping the way we build infrastructure, because the level of security, so the trends that is accompanying now AI, when you go and under the surface, the big incumbent player is the data. And that is also reflecting the needs of having more and more secure infrastructure. So hardware security features, but also software, certificate authority, and this type of innovation. So we are seeing more and more how AI is fusing together with the security and confidential computing environment, because that is a need to protect the actual superstar, which again is data. We've worked on this. We created a federation across 71 clinical institutions. This was a research experiment, but you find all the details in the paper in case you're interested. These are a couple of customer stories. You will have access to these slides, so I don't want to stress you with further example. With Bosch, it's an amazing collaboration because we did use the secure platform. So we've embedded part of hardware features to do security. So it's basically a secure area of memory to compute the algorithm or whatever the code the customer wants to run in a protected area. But this is a simple use case. It doesn't include federated learning. In this case, it's just registration plate recognition. But those are taken from the street, and we need to preserve the entire quality of the image. So in this case, we enter the secure area just to blur any identity, any people that might appear in that picture. And the outcome of this, which is actually outside the secure area, is the same picture without any sensitive information, like the face of this pedestrian. So security is a must-have. The second big trend is to go beyond the buzzword is LLMs versus SLMs. LLM stands for large language models. SLMs is small language models, because we are seeing a shift between research and industry. While research is progressing and in exploring bigger and bigger models, the industry is considering actually going the opposite way. So if you look at 2023, we've seen this explosion of large language models, from GPT to Llama to Mistral to Gemini, Bloom, you name it. And the race was who could make it bigger. Bigger in terms of the more digital neurons you can plug in, the more clever you should get. And that's the rule of thumb. So everyone was rushing towards that direction. Guess what? 2024, it's kind of the opposite, because when you type for example, take a customer, I don't know, a telco company. They want to provide a Q&A or an FAQ kind of chatbot in a more reliable way than the historical ones, where you enter with a level of frustration and you walk out with more frustrations. So if a user types a question into an LLM, for as big as it is, you get an answer, but that knowledge is frozen in time. And that LLM might generate inaccurate answers. And what if that LLM was just not trained on my topic? If I'm a telco and I'm offering a new, for example, SIM card to dialogue with other continents, for example, in convenient cost, I want to provide the answers to that service. I don't care about providing answers to whatever else. And they're expensive to host. So LLM has a lot of parameters, and that means you need more memory and more compute to host them. To generate an accurate answer, we refer to these examples. For example, you have an exchange here where it's not able to spot the letter in a word. Or in this case, if you look at this example in the bottom with the Air Canada, this was an hallucination. They implemented an LLM, and the LLM told the customers that they were eligible for a refund. Unfortunately, the LLM made up this story from scratch. So the company had to pay the customer because now that was granted, but they immediately pulled the LLM down because it was just providing wrong information. And if we go, and just to complement what Luis said before, there is this paper that tries to estimate the cost of a single query to ChatGPT. And again, this study is not only to ChatGPT, it's to all LLMs, right? And that was approximately 36 cents per query. So anytime we play with it, there's 36 cents. So that's a huge cost to sustain. So this is where we are seeing the shift. Research is going bigger, and rightly so, because that may unlock knowledge to better understand even our brain structure or our capabilities as humans. But at the same time, the industry needs something that is deployable and it's effective in solving the real world challenges. So what you're seeing here is the schema of a RAG, and RAG stands for Retrieval Augmented Generations. So it might look complicated, but in a nutshell, what you have is a private knowledge database that can be used to populate a vector DB. And so what we are doing here is basically force the LLM to retrieve the information from our source of knowledge. And so then the LLM will basically output the answer. If this looks a bit complicated, let me give you an example. Instead of hiring a person with 1,000 years of experience in something and asking them, back to the telco example, to respond to our support service, it's like we hire a 10 years old kid that has just learned to read and write. And we give this kid a book. And we ask the kid to study the book. And then any question that the kid will be prompted with, if the answer is contained in the book, provide that. If the answer is not contained in the book, just say you don't know. It's fine to have an LLM that says, sorry, I don't know how to answer to this question if it's a completely unrelated question. Nobody cares about having a gigantic LLM that blows a lot of memory and compute, and that can tell you what's the best recipe for the carbonara, but is not able to answer you what is the cost of the service or how you can unlock a feature or how you can actually overcome an issue with my service that I'm offering. So this is the way to go. RAG has the advantage of reducing the size of the LLM that you need. Again, the equivalent, the analogy with a kid, 10 years old kid is good because you do not need a huge brain as long as with a lot of knowledge, you're not actually leveraging the knowledge in the brain, the digital brain. You're leveraging the knowledge of from your, in this case, is a vector DB, but it could be a website, it could be a Word document, it could be a PDF, a video, you name it. So the long story short is that you can leverage the knowledge of your own source of information. And for that, all you need from the LLM is the ability to read and write. That's it. And if you can do this with a smaller model, it means that you can host that model into a laptop, for example. And that comes with a privacy implication, which are good, because if you can keep your data local, then you are more privacy compliant and you're exposed to less risks instead of sending the information to a cloud and get the answer back. So again, just to wrap it up, LLM and GenAI is a subset of artificial intelligence, is not all of it. And just because it's intelligent, it doesn't have to be complex. So if you want to do this properly, try to find the AI that best fits your need. And this is an important thing to implement if you want to get this AI revolution right going forward. LLM and GenAI cannot solve everything. The use case determines the choice of the technology to be used, not the other way around. So don't go for a technology and then plug in a use case. Try to the better study you can do beforehand on what you need to tackle, what data do you have available, what are the performance expectations that would make you happy. Then go and pick whatever the market has for you to optimize that solution. And with this, I close with a couple of pillars from Intel to maximize the value in this area of AI everywhere. So as I mentioned, the AI PC, it's a new category of AI, a laptop that allow you to host these AI applications efficiently from a battery perspective, but also from a privacy, because you can keep stuff local. And this is a new invention driven by the AI, because we've embedded it alongside the CPU and the GPU. There is a third component called the NPU. We expect this to just be the starting point, and to have this as a standard offering in every single package. Secure and responsible. is a must-have. So look out for the hardware features that can allow you to implement this security at all levels, not only software. The more secure you are, the better it is, because there's no such a concept of 100% security, unfortunately. And deploy and run everywhere. So really tailor the hardware of your solution based on what your use case is demanding you. And this goes through data center to AI PC, from cloud to edge. And with that said, again, highlighting the responsible AI. And here's some question for you to walk away with. As I said, the slides, you will have access to the slides, but it's just a few thought-provoking questions. So the first, if you don't know where to start, find out your pain points, the bottlenecks, use AI responsibly. So start from what is yet to be solved or can be optimized. And once you've identified that, consider whether buying or building the AI application. And then the last but not least is think about how mature you are to embrace this journey. Thank you very much. I will stop sharing. And back to the next speaker, which is Serban, I guess.
Hey, good morning. Thank you very much, Walter. Let me try to do the same and put everything in one piece right now. Really appreciated the time for everyone, and let's start taking it forward from what Walter left us with. Well, the GenAI is the topic of IT today, right? And I will say, well, it's not just IT, but the general public as well as other where people are starting to experimenting with those models. We mentioned about ChatGPT, we mentioned Llama, Mistral, Gemini, Copilot, and so on and so forth. Today, we'll talk about the unique needs of organizations and how GenAI can be used to add value, and I would say immense value. Our theme for our messaging around AI is to bring AI to your data, and it represents that unique value proposition. My name is Sherban Zernovan, and I'm leading the technical computing team into data center sales at EMEA level. Now, immediately I'll make my computer to work. Is not I think from the previous discussion, it emerged immediately that AI, it becomes a category by itself. We believe it has the potential to be historically transformative technology along the lines we saw with the dawn of the internet. Let's face it, we are in generative AI infancy. Company introduced to the technology and this year are aggressively evaluating exactly how it can deliver the value, increase productivity, efficiency, reduce cost, even develop new business models. They're asking what use cases will deliver a return of my investment. And suddenly the focus is coming on the return rather than on the investment. They're also evaluating what are the requirements of for the ecosystem. Is my data ready, organized, accessible? What infrastructure do I need to handle to increase the processing demands? Where will I manage these huge and sensitive workloads? Will it be in the public cloud, my data center, a co-location, a hybrid approach? And most important for Dell, they are asking, who can I turn to help me with this? Dell is building a compelling portfolio for GenAI planning, enablement, and managed services. And into the views we had earlier from Luis and also from Thomas, we saw that the market is really expanding, right? So we are looking for an 18% aggregated growth rate for the hardware and services, but probably even very interesting into this slide, not number the tokens and a lot of data related to specific domain of GenAI. But I think what is really important to understand is that 50% of the spending of the GPU accelerated servers is expected to be on-prem or at the edge, right? So moving into, whatever it was put it till now, I think that when you are looking to the use cases, one conclusion immediately surface. There is no one size fits all type of approach. The dominant use cases for GenAI today, chatbot queries, right? Users are prompting public large language models for suggested response to their queries. Helpful? Yes, but the use cases mature extremely rapidly and they will definitely explode in numbers. Let's consider another analogy. Think about internet use case today, right? We are speaking about e-commerce, we are speaking about social media, cloud computing, data storage, content streaming, VoIP, document sharing, news distribution, thousands of others. Multi-trillion-dollar industry have been built around internet capabilities. But in the beginning, I don't know if you remember this, well, if you know this sound, this means that you are either very old or a nostalgic. I am born into that area, think early 90s, where essentially we use for just an email. You remember the America Online, you've got mail, right? Now, this type of evolution is what we are expecting to see in generative AI. Large language models, the data source behind GenAI, will get smaller, specialized, and more accurate. There will be GenAI models built for specific companies for verticals like healthcare, education, government, retail, you name it, virtually everything. GenAI workloads will be designed to run in all types of environments. And we suspect most organizations, like with their multi-cloud deployments, will take hybrid approach to GenAI, running a combination of on-prem, in cloud, and at the edge. The PCs, which were mentioned by Walter earlier, are now even getting specialized processors called NPU that will allow them to run distributed AI models on the PC. So we've not even really scratched the surface of this enormous transformative potential of this technology. There are other benefits for retaining sensitive data on-prem. It's also more efficient and effective to bring AI to your data than vice versa. Because of that, we are seeing that nearly 80% prefer a primary on-prem or hybrid generative AI model. And further, 42 said that they are ready for the bulk of the data to come from the edge over the next 5 years. So companies are gearing their ability to capture, sort, store the vast data sets that are being produced at the edge. They want to make sure they have their data center, but they also know that inferencing will happen at the edge. That is, GenAI modeling will happen remotely where the data is collected and still controlled by the organization. So what do we do now? Well, AI is transforming business at an unprecedented pace, and enterprises are under immense pressure to accelerate AI initiatives, to compete, innovate, improve how they operate. Now, this change creates challenges. I believe we are hearing the same things. AI implementation can be complex, and many organizations lack the necessary expertise or the necessary expertise to proficiently address these challenges. There are also the complexity inherent in the data readiness. The right data is crucial for AI success, but many organizations face data challenges, including a lack of usable or relevant data, integrating diverse source, data preparation, data access, governance, the right exercise. And organization ability to manage these aspects can dictate is success. Certain implementation of AI, as a second point, can create the risk of data and IP leakage, privacy issues, data sovereignty challenges. Risk of getting this wrong have been publicized, and I don't want to refer them here. You cannot afford to jeopardize your data or intellectual property. And then third point, while AI skills and talent strategy are top challenge for adopting AI, once companies start implementing it, costs become evident. AI can be expensive. There are high acquisition cost of advanced technologies, unpredictable cloud computing costs, the need for specialized skills, and consideration of AI workloads energy consumption, back to Louis' point of view related to sustainability. So what can we offer? We can help you harness the power of AI more quickly by overcoming the most critical obstacle in adopting AI, tackling complexity, risk, the expensive of diving into and supporting AI in the future. So customer can definitely benefit for leveraging our integrated infrastructure that make AI simpler and augmenting skill gaps with our expertise. The second one, ensuring their most valuable data remain protected, managed, and accessible. And the last but not least, right-sizing the AI investment to fit your own use case and requirements with our extensive AI portfolio and integrating our energy efficient technology to lower the cost, right? So I would say that this get to something which is very close to my heart, because I really like the answer on this slide, because it addresses not only how we are enable AI in our offerings, but also how Dell is using it internally. This is in our in, on, for, and with strategy. First, we've been enabling AI in products for many years, like examples like Cloud IQ or the integrated Dell remote access card or open managed enterprise solution into our servers. It's part of the intelligent software that manage VxRail and PowerFlex architecture and part of our automated lifecycle management. This solution use AI to reduce the overhead and the managed complexity of these products. Probably our biggest focus is on our capabilities for running AI on our portfolio. This is where we address our AI customer offerings. GenAI systems are not just a single component. They are a system of technology that comes together to create outcomes that companies are looking for. The solution is a coordinated system of servers, storage, networking, client, and professional services. And only Dell has the breadth of portfolio to provide components across the entire system. That's a huge advantage for us. Next is integrating AI for Dell and for our customers. These are our own adoption patterns for AI, and our customers have a keen interest in how Dell, as a leading technology innovator, is making our own use of this technology. And I think you'll see Dell start to invest more heavily in this story, because we see that we are significantly ahead of most companies in this space. And finally, AI with is our building on an open AI ecosystem with the partners. It's not a solo, it's a tango. It's a work in many. That has one of the broadest and deepest. This gives our customers choice for which platform to deploy, support, based on our long-standing philosophy of enabling open standards, which we believe helps Dell democratize critical technology for widespreading adoption. No one has a monopoly of innovation. So we work together with hundreds of different companies to deliver solutions that meet our customer where they are. And this brings to what you saw the week before, into the Dell technology world. There is a need to rethink everything. What's needed is a new type of data center that is purpose-built to meet the specific demands for AI. And this is the AI factory. Just as physical factories fueled the industrial revolution, AI factories will power the AI revolution. But instead of physical goods, the AI factory produce actionable intelligence, fresh content, and new insights. At Dell Tech World, we talk in full details on the Dell AI Factory, which represents Dell approach for embracing and implementing AI. We want to help our customer to accelerate their AI investment. The Dell AI Factory helps customers make the most of their data. This is the raw material that powers the AI Factory. Data is the raw material that powers the AI Factory to achieve a desired outcome. Dell brings to the table the industry only end-to-end AI optimized infrastructure portfolio, an open ecosystem of deep partnership with other leading AI companies, and insights and know-how of comprehensive suite of AI services, from strategy and planning to implementation and scaling. A click deeper with the industry broadest AI portfolio, we also recognize customer need to bring AI to their data. Dell helps you bring AI as close as possible to your data sources, so you can minimize latency, accelerate insights, reduce overall cost. We recently published together with the ISG group a study which shows that up to 75% more cost, it's more cost effective than having them into a public cloud. And also ensuring sensitive information remains within your control. When we are looking into the infrastructure, the PCs, the workstations, the servers, the storage, the data protection, networking, all of them form the foundation of the Dell AI Factory. We offer the industry broadest AI solution portfolio, spanning from desktop to the data center, to cloud, and out to the edge locations, allowing you to right-size your AI investment and giving you the flexibility to run AI everywhere. And we are doing that providing a silicon diversity to allow the freedom of choice to our customers. Just like physical factory needs a robust supply chain to succeed, AI Factory will depend on a large and dynamic AI ecosystem for their success. As I mentioned earlier, Dell has a proven history of nurturing open systems, PC, and storage, and multi-cloud, to give our customers greater access to innovation and flexibility. Dell is playing a leadership role, driving the right AI ecosystem partnership and championing the needs of organizations that want to maintain their data sovereignty by bringing AI to their data. Like, we are the first to deploy Hugging Face on premises. An AI factory must, much like the physical counterpart, needs a skilled team to succeed. But AI-ready skills are unfortunately in short supply these days. At Dell, we know firsthand how to deploy AI at scale and have extensive global experience guiding our customers to the same. In a nutshell, the Dell AI Factory transformed the data center from a cost center into a profit center, and it drives the business outcomes of our AI Factory with the potential to extract new insights, foster innovation, and definitely bolster the productivity. So, as a last slide from my side, you saw documents, you saw validated design, you saw reference architecture that put together the software, the compute, the storage, the networking to reduce time to very lower the risk, all with industry standards and open design. We have a broad compute portfolio with the PowerEdge servers and with the AI proposed build XE series servers. You'll get the industry best AI performance for generative AI with a portfolio that more organizations rely for, why not to call it, #1 worldwide server plus storage infrastructure provider. And if you are pairing this compute with industry-leading storage that delivers the world's most flexible, efficient, and secure scale-out NAS to handle large data set and offer extreme concurrency, you can take advantage of the multi-cloud file, object, and blocks portfolio. And finally, you are supporting your data scientist and running more modest models locally, SMLs, by taking advantage of the #1 worldwide leader in workstation. Now, supporting all of this solution is the Dell Professional Service, which offer a variety of services. We discussed a lot of models, and if I have to consolidate and resume all in a short message related to what is important and how and when use such models, I really think that we can into a 4-step approach. Step 1, determine your objective. This is what you want to do, achieve, what the outcome is. By understanding your objective, your KPIs, that will help you determine the use case. Step 2, identify the use case. While use cases can be implemented through any AI patterns, certain use cases may benefit from one pattern implementation versus the other. Determining the use case will also help you determine the scope of the effort. Step number 3, decide on the AI pattern. With an understanding of your objective and use case, you can determine the right pattern to achieve the right results with the right balance of performance, risk, and cost. Last but not least, right size your investment. Depending on the pattern you choose, you know how to better scope and optimize the infrastructure you need for what you want to build. I want to thank very much for your time today, and I want to stop sharing and moving back to Luis. Luis, back to you.
He seems to be frozen.
It looks like. Nicolo?
Yeah, thank you very much, Sherman, Walter, and Thomas. I don't see any questions from the audience, at least yet. So maybe something I would like to ask you that came to my mind after hearing all your presentation. So we heard about Walter, having trying to demystify some buzzword. I just wanted to ask, what do you think are the biggest misconception when it comes to AI? Because I believe there is a sort of negative narrative which goes around, let's say, and if the industry is also doing something to change this sort of bias or negative narrative, and how do you see this going forward?
Let me start first, if possible, Nicolo. I think that one of the narrative you are hearing more and more often is the fact that AI will replace the humans and they will move away and things like that, right? I think that the first thing we are going to see is that people using GenAI replace GenAI replacing people, right? I also believe that there will be a shift into the knowledge worker versus the technology, the skilled worker. So, when you have a person which has thousands of years of experience, it is very hard to replace. But when you can get a person able to access that knowledge, it will definitely help to replicate the information much faster. And probably the last thing I want to call out, I think that at this moment is a lot of lack of standardization in the GenAI field. There are an incredible number of startups, model frameworks, and this is where I think that the industry will start asking. Every single chief AI officer I'm meeting these days is giving me the same message: simplify my life, get something which I can understand, and how can I transfer. The last point is, yes, back to Luis' point, the consumption of power of today infrastructure, which is required to support large language models, or even some of the large fine-tune or solution, that requires a proper planning, and the shifting between OPEX and CAPEX here will require some time to get to readapt. That's from my side.
Yeah, from my side, the consideration is really on the importance of going beyond the hype again. I mean, AI right now, even the ability of LLMs needs to be understood, because otherwise we're not going to take full advantage of it. LLMs can only, as of today, can only combine words in the most likely way to it was learned. So I smile because sometimes I see on YouTube or on these social media platform tutorials on how to leverage a LLM to perform a market search. Well, 90% of those are not even connected to the internet, and so whatever is providing as output is made up stuff. In the best scenario, it's stuff that it recalls from the training set, which of course is going to be outdated if we use it today, and it was trained on the data from yesterday. So it is not, we need to be cautious, very cautious in splitting, and I'm saying this from a technology, let's say, from a geek perspective, right? Because I love what I do, I love my job, and I love technology. But for as much as I love it, we need to be able to draw the boundaries of what a tool can help us with versus what is not able to do. Maybe yet, but it's not able to. For example, if we need to summarize the email, if we need to summarize a report, for example, the output of this calls, transcriptions, draft up an email, that's good. Actually, there are examples of AI being used today to check whether we are adding sensitive information in an email before we send it. So it's extremely powerful, but we need to use it as an assistant. Anything beyond this, as of today, is pure speculation, in my opinion. It's just not based on fact, it's based on vision, maybe, which is legit if we need to have the people trusting in investment or this other stuff. But let's stick with our feet on the ground, because there is a way we can leverage this technology today to simplify our lives, but that means that we know and we understood what are the actual capabilities and how to use these tools. Otherwise, nobody will be happy. And so that's what I'm seeing a lot associated with, let's say, the dark side of AI conversations. It's a lot of lack of awareness from both sides, from who manufactures it, because they tend to highlight, the great superpowers that their tool is bringing to the table, instead of saying, oh, by the way, it's not able to do this. And also from the side of who uses it. So I'm also personally invested to go beyond my working hour and the Intel family to educate people in cities and councils about how to make a responsible use of AI as a technology. And I think if we work collaboratively on these two binaries, the dark side of AI, as we called it, is likely going to disappear or be resized. Because at the moment, I think there are fears that are projected on walls, which are just good exercise for fictions.
If I may add to that, Walter, and to your point, it's almost like it's almost like when calculators came around, right? So a calculator can do a lot of complex math that we can also do, obviously, but it would take us a long time to do those complicated, like a multiplication of two very high numbers. It would take us a long time, and the calculator does that instantly. However, it cannot develop new math. Like you cannot ask a calculator, calculate the numbers to get to Mars. Like it cannot do that. It cannot create new math. It can only help us make simple what would be very complex for us to do, but that we can do, but it's very complex and it can do very easily and very rapidly. So that means that instead of focusing on one complex task, we can actually look at 200, 2,000 complex tasks, because the calculator will be able to calculate those 2,000 complex tasks very, very rapidly or instantly even, right? But it's not going to replace the math itself or the mathematician creating new math. Another point would be, this is not related to the question, sorry. I was just wondering, there's a question in the Q&A, but I'm not sure who it is meant to be honest. It says, for greenfield large-scale manufacturing, what is the optimal roadmap of such a decision making / planning? I'm not sure, Walter Serban, do you think that could be for one of you? Because to be honest, I'm
Yeah,
not...
I think, you know, getting back to that discussion is one of the 4 steps I mentioned, right? So determine your objective, identify the use case, decide the AI pattern or type, and then right size the investment. The way we are actually running this as a practice, we are practically engaging into an AI workshop in which we are learning together with the customer what is the scope, what they really want to achieve, and then building from there without trying to position specifically a technology or infrastructure, because they are not 2 use cases the same. This is what we learned over the last 2 years.
So maybe we could close. So thanks again for your insights. So maybe we could close it with us, I don't know, like a very high level statement. Now, do you see this sector specifically? You know, and maybe if you could also have, you know, an insight on the semiconductor sector specifically in the next 5 years. So which challenges do you think you know, Europe should address in also from a vendor perspective, from an industry, I mean, perspective?
Who should start? Maybe I can start. So 5 years plans and this sort of thing. I noticed that both Walter Serban and Thomas started smiling when Nicola said 5 years, because we don't know what's going to happen in like 6 months, right? But anyway, I would say that obviously I would leave out for now geopolitics, because we know that this year is going to be very crucial for various reasons. Whatever the outcome might happen on the other side of the pond in November, but it will be very critical. However, I do feel like what I've seen for now is that I think there's going to be a diversification in the semiconductor industry, both from a design standpoint, but also from a manufacturing standpoint. Just the question of diversifying across the globe into different hubs, because it's not only a geopolitical question, it's also a question of nature. So we're obviously having climate change events that are very drastic. And if we have manufacturing very centralized in small hubs just in one place in the world or 2 places, there could be the question of having some limitations in the supply chain, which can be very dramatic. We saw things like the Suez Channel being blocked for weeks because of one ship, or the Panama Channel not having enough water for huge boats to circulate because of climate, or maybe there's a hurricane in Southeast Asia and all of a sudden nobody has SSDs to put in their servers and laptops. So there's going to be that diversification, and I think the EU will play a big role in that, because we do have the expertise. We just have to figure out because we've been outsourcing all of the manufacturing part to other parts of the world. How can we bring back to the EU, or at least closer to the EU, to have the whole supply chain and not being so dependent on others? But maybe Thomas can elaborate, how can we do that? I think that's the most crucial step in the next few years. Aside from the whole power thing, how can we have secure our own manufacturing and our own supply of semiconductors to the industry without having to depend so much on others? It's a global economy, so everyone depends on everyone, but not be so dependent, I'd say.
Yeah, thanks, Luis. Yes, from the European Commission side, I think what we try to do is, I hope you hear me now correctly, to have the whole framework quite well done. So today we have a lot of legislation in place, like mentioned before, the GDPR. Then we have, again, for the Data Act, putting here clearly some new networks together. We have the artificial intelligence regulation coming out. We have the CHIPS Act, which pushing, I would say, on the semiconductor side, pushing for new fabs, for new prototype lines, and trying to put for semiconductor goods infrastructure here in place, or a minimum on the pipelines. And the other thing which was not mentioned was the Cyber Resilience Act, which is quite important, because we heard in several presentations that cybersecurity will be one of the decision points for this artificial intelligence and how to use this. And their Cyber Resilience Act will probably be one of the keystones in that sense. And the last thing is, what we have not done here is exactly the labeling, and the labeling is from the energy side. So what needs to be done there is still unclear. It doesn't make any sense to label, for example, the chips on the power supply, but probably we need to look into whole systems, how to do the systems, if we're doing the AI in the cloud or in the edge, or how we will do that. And especially there, I was really pleased to hear about standardization. Is quite something which goes where a lot of people are pushing on that. So and especially open standards, which you can access easily. I think this is a key things, and we really will push, I would say, from a voluntary perspective, to have this enabling network through standardization. Thank you.
Just a small note. There's a question in the chat. Sorry for cutting off. What is the scale magnitude of the related costs? What are the OPEX, CAPEX considerations? Would someone like to take that one, or should I?
Well, really depends on what you want to achieve. You know, what what's the purpose, right? So we have, Walter mentioned already, we have models which are Olama, which are able to run on a laptop. I had recently a discussion with a professor in Italy, and he told me that he is able to run an LLM on a Raspberry Pi. So, you know, it really depends on what is the use case. You know, it's very hard to provide. You know, when you are transferring from and you get used to have a usage as a service, and then you have to rebuild that infrastructure because of many constraints, data gravity, security, whatever. My logic says that wherever your data is, that is where your AI should stay.
Yeah, and it goes back to what I shared before, right? About size the infrastructure and your decision based on what you need to implement, because otherwise is not optimal. It might be quick because you go and shoot because you have the recipe from others. Yeah, you save time, you're not saving money. If you're trying to do it in a cost-efficient way, then planning is the key. And including in planning is the clarity of objective. Where do you want to get? By when? What performance do you expect? And from them, you shape the choice.
Agree.
So thanks again. I think we reached the end. Thanks also for staying us a little bit over time. Again, to the audience, we'll be uploading the slides and the video recording on the ALLPROS.eu website, and we'll be sharing with you in an email. So thanks again to all the speakers and Luis for having organizing it. It was very insightful, very interesting. And we'll keep you up to date for the third webinar on this series very soon. Thank you again and have a good day. Bye.
Thank you. Bye.
Thank you. Bye-bye.